Okay, new chapter, chapter 5, and the first section's on trigonometric functions. Good news. The first two sections here, there's lots of review from last year. Most of it's review from last year. So it's kind of a nice way to start. The first thing we're going to talk about is angles and standard position. So we did this last year. Angles and standard position is when you have a coordinate plane, right, an x-axis and a y-axis. And if an angle's in standard position, it has its vertex at the origin. Okay, maybe I'll write that. Vertex at origin. And then it has one of an angle is made up of two rays, right, that meet at a vertex. One of the rays runs along the x-axis in the positive direction, not in the negative direction. This is called the initial arm or the initial side. And then the other ray is rotated. If it's rotated in the counterclockwise direction, it's going to be a positive angle. If it's rotated in the clockwise direction, it's going to be a negative angle. So let's just put it up here. And if this was the case, and if you were measuring this angle in here, this would be a positive angle. But if you were measuring from this initial side all the way over around to here, this would be a negative angle. And the one thing I didn't do yet is I didn't label this ray here is called the terminal arm or the terminal side. Okay, degrees. Well, you know what degrees are. It's one way to measure angles, and with degrees, one full rotation, like all the way around, is 360 degrees. So what that means that 1 degree is equal to 1/360th of a full rotation. Okay, which quadrant are the following angles in? So let's think about this for a second. Here is 112 degrees. You don't have to actually draw these, but just to help us out. 112 degrees, we would have our vertex at the origin, and the initial side would come out here. This is 90 degrees, so it has to be, yeah, like if it was like this, it would be 90 degrees. If it was like this, that'd be 180 degrees, and 112 is between those two things. So the terminal arm must be somewhere in this quadrant here. So that is quadrant 2, right? The quadrants go 1, 2, 3, 4. Negative 325, okay, again, just to help out, I'll draw this, whoops. So there's the initial side. It's a negative angle, so we're moving this way. This would be 90. This would be 180. This would be 270. And all the way around is 360. Well, 270 and 360 has to be somewhere between there if it's negative 325. So it must be in here, and we're measuring it around that way. So it is in the first quadrant. If it's 800 degrees, okay, well, here's our initial side. This would be 360 degrees. Another rotation would be another 360, which is 720. And then we only want to go 80 more to get up to 800. So it'd be right around there. So it would look like there's our terminal side there. And so it would be in the first quadrant. Now, one thing we're not going to talk about today, but it will come up, is remember, once we've figured out that 800 degrees is the same as 2 complete rotations plus this little bit here, remember that little bit there, which is actually 80 degrees? That's called a reference angle. And we'll talk about that in a couple more classes. Maybe next class, I can't remember. Anyway, that's a reference angle. You don't need to know it for today, though. Okay, coterminal angles. I don't know how this popped up. I must have accidentally clicked it, but here it is. They have the same initial side and the same terminal side. So for example, if I was to draw an angle in standard position, let's make an easy one. Let's say it's 100 degrees. So here's the initial side, and 100 degrees would put the terminal side somewhere around here. This is 100 degrees. If I wanted to get coterminal angles, it would mean it would have the same initial side and the same terminal side. How could that be? Well, there's a couple ways you could think of it. You could think of it as we're going to measure the angle from this same initial side, but instead of stopping here, we go all the way around like that. So how much would that be? Well, that would be the 100 degrees plus another 360. So another coterminal angle would be 460 degrees. You could go another 360 and get another coterminal angle, and another 360. You could do this infinite number of times, right? Okay, the other way you could get a coterminal angle is go in the negative direction. So what if we started at the same initial side, but we went this way to get a negative angle? How much would that be? That would be 100 minus 360. Negative 260 degrees. So it's very easy to get coterminal angles. Either add successive 360s, add one 360, you'll get a coterminal angle, add another 360, you'll get another coterminal angle, or just subtract 360s. Subtract one 360, you get a coterminal, subtract another 360 from this, you get negative 620, that'd be another coterminal angle, subtract another 360, that'd be negative 980, it's another coterminal angle. You could do that forever as well. Okay, so getting coterminal angles isn't too bad. Alright, next question here is to actually find some coterminal angles. So if we want to get one positive and one negative coterminal angle for each of the following. A positive coterminal angle to 168, what could we do? We could just add another 360. So you'd end up with 528 degrees. If you wanted to get a negative coterminal angle, you would subtract 360. And 168 minus 360 is negative 192 degrees. Okay, negative 400 degrees, we want to get a positive coterminal angle, so we'll add 360 degrees. We get negative 40. Hey, we didn't make it. So what should we do? Add another 360 degrees. And you end up with 320 degrees. Hey, look, we have exactly what we wanted. Another negative coterminal angle and a positive coterminal angle. So we've done exactly what we needed to do. Okay, here's something new. Radians. Radians is another way that you can measure angles. So remember on your calculator, I've told you up till now, make sure your calculator is on degrees or DEG or DGR. Don't have it on rads. Well, this is what a rad is. A rad is a radian. It's another way of measuring an angle. So what a degree is, or sorry, what a radian is, it's the ratio of arc length of a circle divided by the radius of a circle. So, for example, let's put a circle here. First of all, let's draw the radius. Here's a radius here. There's a whole bunch of radii, right? Infinite number. But there's one way of looking at it. There's the radius. Let's say that this radius is, well, let's call it r. Why not? That distance from there to there is r. What an arc is, an arc length, is when you start traveling part way around the circle on the outside of the circle. And this would be a certain distance, right, as we move here. As soon as you've gone the same distance, like if this distance here is r, as soon as I've gone r units this way, then the angle that's formed is a radian. That's how much a radian is right there. Okay, so let me do another example to help you understand that. Let's draw a circle. Let's draw a radius. You don't have to draw it out this way, but we usually do. Let's say that this distance right here, let's say that this is 2 centimeters. And then let's say that I start at this point here and I measure along this circle and I go up 1 centimeter. This distance here is only 1 centimeter. The blue line there, the blue arc, is only 1 centimeter. So what would be the measure of this angle right here in radians? Well, to get the measure, you take the arc, 1, and divide it by the radius, 2. So the radians, number of radians it is 0.5. It's 0.5 radians. The way you show that is just 0.5, like you don't put anything. You don't put a degree sign, that would mean degrees. You either just put 0.5 or you put 0.5 rad. But often you put nothing, which can be a little bit confusing. Now, let's go back, same circle. Let's say again it's 2 centimeters. But let's say this blue line here, I extend it all the way up a little further, that it's now 2 centimeters. This is 2 centimeters, the radius, and this is 2 centimeters along here. How big is this angle in radians? It's 2 over 2, which is 1. This is 1 radian right here. Okay, let's do one more. Let's say I continued going around here, and I went all the way to, I don't know, 4. All the way around here is 4, let's say. How many radians would it be if I connect that? How many radians is that angle right there? That angle is 4, that's the arc length, divided by 2. This is 2 radians right there. That's the idea of radians. It's a comparison between arc length and the radius of a circle. Okay, well now let's take a look at a very important circle. It is called the unit circle. So, a unit circle we will talk lots about in this chapter. We're just going to talk a little bit today. A unit circle involves a circle drawn on a coordinate plane. So the important thing about a unit circle is that it has its center right on the vertex. And the other important thing about a unit circle is that guess how big its radius is if it's a unit circle? The radius is 1. So this distance from here to here is 1. This is called a unit circle. Now, what might be useful is to figure out how many radians there are in one complete rotation. So for example, if we go back up here, you know that one full rotation in degrees is 360 degrees, right? But how many radians is one full rotation? Well, we can figure that out just by using this same formula right here. The number of radians in a full rotation will be equal to the ratio of the arc length of a circle. Well, for the arc length, we're going to do the arc length, make the arc the whole way around the circle. What do we call that, the whole way around the circle? We call that circumference. So the number of radians in one full rotation, number of radians in one full rotation equals the whole way around, which is called the circumference, divided by the radius. Now the nice thing about the unit circle is that the radius is how much? 1. Circumference, how do we get circumference? We go pi times diameter, or diameter is the same as 2 radiuses, so it's 2 radiuses times pi. And again, this is very nice because the radius is 1. So you get 2 times 1, which is 2, times pi. So you get 2 pi divided by 1, so just 2 pi. One full rotation is equal to 2 pi. One full rotation equals 2 pi. Well, now that we figure that out, this is 2 pi radians, right? Now that we figured that out, we can figure out how many radians there are in a degree, or how many degrees there are in a radian. How are we going to do that? We're going to equate this 2 pi radians with the 360 degrees. Let's do that on the next page. So what we've seen is that one full rotation is equal to 360 degrees, and that same amount is equal to 2 pi radians. So these two amounts have to be equal to each other. If we divide both sides by 2, we can make it a little bit simpler. We can say that 180 degrees, halfway around a circle, is equal to pi radians. By the way, have I stated, you might be saying to yourself, what the heck, why would we bother with this radians thing? Numbers like 180 degrees are way easier than having pi of something. The reason is that, believe it or not, when you get to calculus and some engineering aspects and stuff, but for most of you it will be calculus, it's easier to work in radians than it is with degrees. You get more precision, more accuracy often. Alright, let's figure out how to switch from degrees to radians or from radians to degrees. This is very important. To switch from degrees to radians, what you do is you multiply by pi divided by 180. And to go from radians to degrees, you multiply by 180 divided by pi. So let's try some of these. If we're going to change from 140 degrees into radians, so we're using the top formula, we're doing 140 and we're multiplying it by pi over 180. Okay, let's get this in simplest form. We can cross out this and this, the two zeros, divide them both by 10. And you can also divide the 14 and the 18 by 2, so you get 7 and 9. So our final answer would be 7 pi divided by 9. That's a great answer. Now, if it asks you for a decimal answer, of course, you could do 7 times pi, 7 times 3.14, or use your pi button to get a better answer, and then divide it by 9, and you end up with something like 2.44. But usually, you're just going to use this as your answer. You're going to leave it with the pi sign in it. It's more precise. Okay, let's switch negative 600 to radians. So negative 600. The negative will make no difference here, right? You'll just stick around the whole time. And we're switching it to radians, so we're multiplying by pi over 180. Again, we can cross out the zeros by dividing by 10. Something that goes into 18 and 60. How about 6? I don't know if there's anything bigger. 6 goes into 18 3 times. 6 goes into 60 10 times. And I think that's it. So we're left with negative 10 pi over 3. You could use your calculator to get a decimal, but this is a great answer. Let's change these ones into degrees. So to switch to degrees, we multiply by 180 over pi. So pi over 4, and we're multiplying by 180 over pi. Nice, the pi's are gone. 4 goes into both of these. 4 goes into 4 once, and 4 goes into 180 45 times. So you're left with 45 degrees. Next, 2 pi over 3 times 180 over pi. Okay, you got 1 pi on the top, 1 on the bottom, get rid of those. 3 goes into 180 60 times. 2 times 60 is 120 degrees. Okay, this one looks a little different. It doesn't have a pi sign in it or anything. Remember I said that you could, if you want, switch the radians into decimals. If you do that and you get an answer like negative 1.5 and you want to go back, you still do the same thing. It's just now you will get a pi sign. They won't all cancel. So you multiply by 180 over pi. Obviously you can't cancel out that pi. So if you were to multiply this, pick up your calculator and multiply, you're going to get negative 270 over pi. That's fine. Or you could take your calculator and divide 270 by pi, and you'll get something like negative 85.9 degrees. Okay, arc length. Arc length is the distance of an arc, right? It's how we already talked about this a little bit. If I draw a circle, an arc is part way around the circle. So arc length is asking like, how long is that? Or how long is that arc? Or how long is this arc all the way around there? Arc length. So when we figured this out with radians, we said that the angle in radians was equal to the arc length, which is symbolized with an S, believe it or not. Don't like that, but that's what it is. It's S. We said it was equal to the ratio of arc length divided by radius, r. So if we just rearrange this and we want to isolate the S, our formula for arc length would be S equals, we just have to move the r over and multiply, so it would be r times the angle. So just to make sure you're clear what all those things are, S here is arc length, r is the radius of the circle, and this is the central angle. And it's very important that you realize it's in radians. You must have it in radians. Won't work if you have it in degrees. Okay, a pendulum 30 centimeters long swings through an arc of 45 centimeters. Okay, so we have a pendulum, and it's 30 centimeters. And it swings from there, and it swings over to about here. And it has an arc of 45 centimeters. So this is 45 centimeters. Now, how does that relate to what we're talking about here? Well, if you were to extend that arc all the way around, you'd have a circle, wouldn't you? Whoops, that's terrible. But hopefully you get the idea. So we're going to use this formula, this S equals R theta. And we're looking for the angle. So I guess if you wanted to, you could rearrange the formula so it actually looks like this. The angle is equal to S, which is the arc length. What's the arc length? 45, they give us that. Divided by r, the radius. What's the radius of the circle? 30. So the angle is equal to 1.5. 1.5 what? 1.5 radians. It says to give the answer in radians and degrees. So if we want to switch 1.5 radians into degrees, you need to multiply by 180 over pi. That gives you 270 over pi. Hey, it's the same answer we got up here except positive. Interesting. That was a fluke. So it's the same as 85.9 degrees. Okay, you can have 270 over pi degrees. You can do that. That's fine. Calculate the arc length of a sector of a circle. So a sector of a circle is like a piece of a circle. The diameter is 9.2 and the sector angle is 150 degrees. So this angle in here is 150 degrees. This whole region here is the sector, and we want to know the arc length, so we want to know this blue distance from here to here. And the other piece of information we know is that the diameter is 9.2. Okay, if we're trying to get arc length, we're going to use this. arc length equals radius times central angle. The radius is, it doesn't give us radius, but it gives us diameter. What do you do diameter to get radius? Divide by 2, so you get 4.6. You're going to multiply that by the angle, so should I put 150 there? No, you should not, because it has to be in radians, so you need to switch this. 150, you're going to have to multiply that by pi over 180. So you can divide both of those by 10 to get rid of the 0, and then divide both of those by 3. You'll get 5, you'll get 6, so you get 5 pi over 6. That's what you need to multiply this by. 5 pi over 6. I think now I just take my calculator and multiply. 4.6 times 5 times pi, divide it all by 6. You get 12.0 meters. And that's the final answer. Okay, there you go. Nice introduction to trigonometry in grade 12.